In this example, we're looking at a straight, thin, circular shaft, which is loaded with this torque T. There's two constraints on how much torque that this shaft can carry. One is that the maximum shear stress cannot exceed the allowable of 10 ksi, and the angle of twist over the length cannot exceed the allowable value of phi there of 0.1 radians. With these two conditions, what is the value of the allowable applied torque T? I'm going to start out with just writing down the polar area moment for the shaft. Polar area moment, as we know, for a circular shaft is going to be pi over 2 times r to the fourth. R in terms of d here is d over 2. So this gives us pi d to the fourth over 32. In terms of shear stress, we know that shear stress is related back to the torque by T rho over the polar area moment there of J, where rho is the distance from the axis of the rod out to whichever point where we want the stress. So the maximum, of course, occurs when rho is equal to d over 2. So this becomes T d over 2 like this. J, that's pi d over 2 to the fourth divided by 32. So that says that this is equal to 16 times the torque divided by pi diameter cubed. So that's the relationship that we have between torque and maximum shear stress in that shaft. So from this, I'll solve actually for T in terms of tau. So this is pi d cubed tau max divided by 16. The other relationship we need is between the angle of twist and the applied torque. That's TL divided by GJ, where G is the shear modulus of the material. This is TL G divided by J, of course, which is pi d to the fourth over 32. So this is equal to 32 torque times the length of the shaft divided by pi g d to the fourth. From this, I'll solve for the value of torque in terms of the angle of twist, so that becomes pi g delta phi d to the fourth divided by 32L. So these are the two equations we have. And keep in mind we have to meet both conditions in terms of allowable stress and allowable angle of twist. So I will write this T sub tau allowable. That condition there, we just simply put in tau max equal to the allowable amount, which is given. The torque due to the allowable angle of twist, that would be pi g delta allowable. That's the given number that we have. D to the fourth divided by 32L. We solve for both of these. We choose the smaller of the two. Because what we need to do is meet both criteria, so they're likely not going to be the same value T, so we need to choose the smaller of the two. So here is just, again, using our relationships that exist between torque and maximum shear stress and torque and angle of twist. We need to satisfy both conditions, so from that we can determine what that maximum allowable torque is in the shaft.